Alright, welcome back. Today we are starting Chapter 6, Section 5. So we've been dealing with things that are under these roots, and in this section we're just going to essentially take things up a notch in a reasonable way. And we're going to be doing different things with radical expressions. So this is also called a radical sign. I usually just call it a root. But radical expressions are going to be things inside these radical signs, but we're not dealing with like equations or anything yet. There are no equal signs. We're just taking things that are under these radical signs, these root signs, and simplifying them. So let's start with something like this. Let's say we want to simplify the square root of 8x to the fourth power. Okay. It might be good to get into the habit whenever you see a square root here that doesn't have the root number, to go ahead and put a 2 there. Okay. If that root number is not there, it's a 2. And we've been told that we can break this up. We can just multiply the square root of 8 times the square root of x to the fourth power. I'm going to put my little index there on both of those roots. They're both 2. And we're going to deal with each of these separately. So starting with this one, the square root of 8, I can break down 8 as 4 times 2. And the 4 can be 2 and 2. So total, I've got 3 2's there. This index says that I need to circle 2 things at once. So I can circle 2 of those 2's. What I circle, I bring out one of them outside of the root. But see how we have a 2 left over here? That one stays in. So the square root of 8 is actually 2 times the square root of 2. And now we can deal with this. This is actually much easier to deal with. We can just take the exponent of 4 and divide it by the root, 2. So this is x to the 4 over 2 power. 4 over 2 is just 2. Okay. So this example is not in your notes. So if you click open the notes, this example is not on there. The first example is this one. We're just using this one as kind of like kind of a bell ringer, just an opener. You can write out how this one works. That might help. So we've got 2 times the square root of 2, and here we've got x squared. We're just multiplying these together. So we take everything that's outside a root, 2, and then x squared. And since we're just multiplying, we can just squish those together. And then we've got everything under a root, square root of 2. So the square root of 8x to the fourth is 2x squared times the square root of 2. And if you want, you can put your little 2's there on your roots. But usually, at least in the final answer, we try and leave that 2 out, especially if you've got an exponent of 2 here. That can be a little difficult to determine what all the 2's are doing. Okay, so that is the basic way of simplifying a radical expression like this. So in the examples that we've got here in our notes, we're going to do something similar for these. So the first example in the notes, 1a, wants us to do this. We want to simplify now. What we have under here is 25, a to the fourth power, b to the ninth power. So we're going to split this one into 3 pieces. We've got the square root of 25 times the square root of a to the fourth power times the square root of b to the ninth power. And we're going to deal with each of those separately. And I can go ahead and put my little 2's here just as a reminder. Those are all 2. Starting with the square root of 25, you might know what the square root of 25 is off the top of your head. If you do, great. If not, you can break down 25 as 5 times 5. Since this is a 2, we're circling 2 things at once. So we can circle our 2 5's here and bring a 5 outside. So the square root of 25 is just 5. Now we deal with the square root of a to the fourth power. We can use our shortcut. We can do 4 divided by 2 here. So this is a to the 4 over 2 power. That's going to look a lot like what we did over here. That's just going to be a squared. It's going to be multiplied. And we can do the same shortcut here. We can take b. This is the 9 over 2 power. Now this presents a little bit of an issue that we didn't have to deal with here. 9 over 2, 9 doesn't go into, well, 2 doesn't go into 9 evenly. What is 9 over 2? Well, that's 4.5. It's b to the 4 1/2 power. Well, we can take this. It's going to be best in cases like this where it doesn't give you a whole number answer to write it as a mixed number this way. So you've got a whole number and then a fraction. We can put b to the 4th power here. Okay, so we've accounted for the 4 by writing this. Now, the part that's in the fraction, we have to deal with as well. If we've got a fractional exponent here, that's telling us we're going to have to put it back inside this root. So we can write our root sign right next to the b to the 4th. It's going to have a b. Okay, it's got the same base. Now, to denote that it's to the 1/2 power, the denominator of the fraction is the number of the root. And it should match what you originally had. So it was a 2 up here, it's still a 2 here, because this number is a 2. The top number of the fraction is the exponent that goes inside. So this is really a 1. And you'll notice this is a 2. We usually don't write the 2, so this could be erased. And when I write the final answer, I'm not going to put the 2 there. I'm also not going to put this 1 because we usually don't write exponents of 1 either. So let's put what we have all together. This is again multiplied. So we're just multiplying all this together. We're going to put everything that's outside a root, 5a squared b to the 4th. And then what I have here is the square root of b. I'm not going to write the 2 here. It's understood to be a 2. Same thing with this exponent of 1. I'm just going to leave it there. So we've got 5a squared b to the 4th times the square root of b. And that's our answer. Okay. I think you'll find that these two examples put together are about as complicated as something like this is going to get for you guys. Either you've got a number that doesn't go in evenly, so you've got numbers on the outside and inside of the root, or you can have it so that one of the variables doesn't go in evenly, so you've got the same letter outside and inside the root. But now you understand when that happens and why it happens. So, if things are going pretty well, if you understood that, if you think I'm actually going a little slowly, I encourage you to try this one on your own. Example 1b. If you want to look at another example, I totally understand. Let's go through it together. Just make sure as you're watching this video and you're seeing how these work, that you're writing them down, either on the note sheet if you can print it out, or on your own separate sheet of paper. So if you're not writing this down right now on paper, pause the video, go get some paper, write out what we've done so far, and make sure that as you watch how these work, that you're getting them down. I want you to have these whenever you need them for later, because you will need them again. Okay. So, now that you've got your paper and you're writing all these down, let's try this one. We've got a cube root now, so our root here is 3, so we're going to keep that in mind. We've got a coefficient, a number in front here, and then 2 variables, so we're going to be splitting this into 3 pieces, just like we did with this one. So we've got the cube root of 8 times the cube root of u to the 4th power times the cube root of v to the 9th power. Okay. And if you're anything like me, you're not a huge fan of using u and v as the variables in a problem like this because your u's and v's can look very similar. So I'm trying very hard to make these look different. Okay, this is a u, this is a v. It might not always be so easy to tell. We'll see. So let's deal with each of these separately again. We want to find the cube root of 8. You might know what that's equal to. If so, wonderful. If not, you can break it down. That should break down into 3 2's. This tells us the number of things we circle at a time. 3 things, we've got 3 2's. So we circle all of them. And that just becomes 2. So the cube root of 8 is 2. For the u's, my apologies, my cat was being annoying. She's now in the room. So we've got u to the 4 over 3 power. U to the 4 over 3 power. This does not go in evenly, so we want to write this as a mixed number. 3 goes into 4 one time, with 1 left over out of 3. So this as a mixed number is 1 and 1/3. My cat really wants to do these problems. So we're going to write this as u to the first power. Yeah, u to the first power. I'm not going to write the 1 there. It's understood. And then the fraction part is going to look like this. We've got u to the first power in here, and the 3 on the bottom is our root number. Okay? So u to the 4 over 3 is the same as u to the 1 and 1/3 power, which is written this way. This is the u to the first part. This is the u to the 1/3 part. And they get multiplied. Okay, so now we can deal with our v's. This is going to be v to the 9 over 3 power. 9 over 3, that's just 3. So this is v to the 3rd power. Yep. You're noisy today. So we've got all of this. We want to write it as our answer. We're going to take everything that's outside the root and write it first. In alphabetical order is usually how we do it. So that'd be 2 u v to the 3rd power. 2u v to the 3rd power. And then anything inside a root gets tacked on at the end. So that's going to be this. The cube root of u. That's right. The cube root of u at the end. There you go. You're noisy. So there it is. There it is. Okay. So, those are actually the hardest examples that we're going to do today in this video. These last two that we've got are actually much simpler, in my opinion. There are a lot less steps, especially for this one here. So this is a little bit of a palate cleanser. It's a nice, easy one after the ones we just did, which are pretty tough. Pretty tough. The cat wants to go back outside the room, so I'll let you read this one for a little bit and see if you can work on it. All right, we're back. Got it yet? Just kidding, it's okay. It's only been like 10 seconds. All right, we want to simplify this. And this problem introduces something we haven't dealt with before. For all of these examples, we only had something under a root to simplify. Now we're being asked to simplify things that have roots added together. So let's take this one piece at a time. We're going to do everything we can to simplify this separately, and then we'll do everything we can to simplify this separately, and then we'll try and add them together at the end. Okay? So, 4 square root of 2. Is there any way we can simplify this anymore? Well, the only way to do that would be to mess with what's inside here. Can you break down 2 at all? No, it's just 1 times 2. So there's really nothing we can do here. We're just going to keep it as 4 square root of 2. Now, square root of 18. This we should be able to break down a little bit. Okay, so there are a couple different ways to do it. Let's see here. You could do 9 and 2, or you could do 6 and 3. I think that's it. But a little tip. We already have this in this problem, and it's got a square root of 2 in it. So when you're breaking down another root in the same problem, you want one of these numbers to be what's here. You can do it with 6 and 3, but you'll be making a little extra work for yourself. So since this is a 2 in here, and I can divide this number by 2, I'm going to do it that way. So this is going to be 2 times 9. This 9 can still be broken down into 2 3s. So we've got 2 3s and a 2. And this is a square root, so that's a 2 there, which tells us we can circle 2 things at once that are the same. So we can circle these 3s. So we take a 3 outside the root. This 2 is left over, so it stays in the root. So the square root of 18 is the same thing as 3 square root of 2. So we've got 4 square root of 2 and 3 square root of 2. And we want to add these together, right? 4 square root of 2 is here. The square root of 18 we determined is 3 square root of 2. We're adding them together. We want to add these. There is a really easy way to do this that doesn't involve really anything more than being able to add numbers. If these things are the same, if the numbers inside the root are the same, just treat them like x's. What do I mean by that? I'm saying this problem, you're going to treat it the same way as this one. If you've got 4x plus 3x, that would equal what? 7x, right? So if you've got 4 square roots of 2, and I give you 3 more square roots of 2, what do you have? 7 square roots of 2. These roots are still the same root, but you've got 4 of them, and then 3 more makes 7. So you only add the numbers that are outside the roots. Okay? And this only works if the numbers inside the roots are the same. If I had changed this into a 5, for instance, you would not be able to add them together. If this were a 5, you would not be able to do that. You would have to keep it this way, and this would be your answer. But since these numbers were the same inside the root, we could just add those numbers on the outside together. Okay. So let's try one more example here. This one looks a little more intimidating. We want to simplify all of this together, and now we're doing subtraction. Okay. So let's simplify each piece individually. That should break things down into manageable chunks. Is there any way we can simplify this anymore? Well, you can't really break down 5. It's just 5 times 1. So this one's fine. We want to take the square root of 45. We should be able to break this down. And the key here to breaking it down in a way that is nice, you already have a 5 in here. So let's see if we can make one of those numbers a 5. 45 divided by 5. 5 goes into 45 9 times. The 9 can still be broken down, 3 and 3. 5 gets brought down. How many things are we circling at once? Might help to write that 2 there. 2 of the same thing can be circled. So we can circle the 2 3's. They're the same. That means we're bringing a 3 outside the root. The 5 is all alone, so it stays inside the root. So that means the square root of 45 is the same as 3 square root of 5. Okay, and it's nice that these numbers are the same. We're going to deal with that in just a minute. Now we need to deal with the square root of 80. Again, we can break that down. If you want to break this down as 8 times 10, feel free. That's perfectly fine. Absolutely fine. But since we're dealing with square roots of 5 here, I'm actually going to make one of these numbers a 5. And then we got 80 divided by 5. 80 divided by 5. Well, 5 times 2 is 10. And you need 8 of those to make 80. So it's 8 times 2, which is 16. So 80 is 5 times 16. And the 16 can be broken down into 4 and 4. I'll bring my 5 down. Now you can break these 4's down into 2's. You can do that. But if this is a 2, which it is, you only need 2 of the same thing. You don't have to keep breaking it down. You can actually circle the 4's here. Bring the 4 outside the root. And again, the 5 is lonely. It doesn't have any partner to be circled with, so that means it stays inside the root. So the square root of 80 is 4 square root of 5. So we wanted to take 8 square root of 5 minus the square root of 45, which we know is 3 square root of 5, minus the square root of 80, which is 4 square root of 5. So we've got this. And what we learned from our last problem, and this works with addition or subtraction, if all the numbers under the roots are the same, you're only dealing with the numbers that are outside. So as long as you know what 8 minus 3 minus 4 is, you can get the right answer. So what is 8 minus 3? Obviously 5. So this is 5 square root of 5. Minus 4 square root of 5. And then we just need to do 5 minus 4. That's 1. So this is 1 square root of 5. And in fact, if this number out here is a 1, we usually don't even bother writing it. It all just simplifies to the square root of 5. So everything we started with here is just a really complicated way of writing this. So, that was a lot. I packed a lot into this video. If you stuck around until this point, awesome. I hope you learned a lot. Okay, we reviewed how to deal with things that are under roots, both coefficients and variables to a power. We separate them into parts, right? Number by itself, letter to a power by itself. Simplify each one, and then write what's left. Sometimes you get exponents that don't quite work. Write them as a mixed number. Write the whole number part, like this, and the fraction gets put back into a root. Okay, so we dealt with that with these two. And then we talked about if you're adding or subtracting things, break down each term separately, like we did here. And then if your numbers inside the roots are the same, you can add or subtract the numbers on the outsides. Okay. But being able to break down roots both for numbers and variables is going to really come into handy in this section. So if that's what you're struggling with, You can do a little bit more practice. Okay, there's going to be more problems in this section. You're going to get plenty of practice. By the time you're working on the problems, you will have had a lot of exposure of how to break these things down. Okay, so what I really want you to get comfortable with from this section is what to do when things don't quite go so easily. Things like this, things like this. And these rules about getting the number inside the root to be the same. Okay, it's a lot to digest. I might encourage you to rewatch this video again, or parts of it. Maybe if there was a particular example that you need to go through again to rewatch it. But if you write these down in your notes, you've got them now. You've got all the steps. So you've at least got something to look back to when you have to do problems like this on your own. But that's enough for today. Tomorrow we will continue with the next few examples in the notes. But until then, have a great day. See you.